My name is @CraigBox. I work at Google Cloud. I am based in London. As Andrew said, I lead the developer advocacy teams for Cloud Native. I've been working with Kubernetes since 2014, which I suspect is probably the longest of anyone in the room, by virtue of the fact that I managed to join at exactly the right time and hear about this magic Project 7 that we were working on. It's fantastic to be back here in the West Island of New Zealand, so glad to see you all. Woo! Let's hear it for the Kiwis! Don't do that very often, but you know you have to every now and then. So, does the little clicking machine work today? It does. Right, so you might have come to expect a technical conference talk, but no, not at all. This is a talk about bravery. This is a talk about courage. This is a talk about alpha software running in production. It's a testament to everyone over the course of time who has decided to run Istio in production before 1.0, validate all the important use cases. So I'd encourage you to just check under your seats for the gift bag that we've left there. No, of course, I have some bad news for you. I don't have anything to announce today. Istio is not actually 1.0. It's not going to be 1.0. You can check out GitHub today, and you can see that we are, in fact, still at the lovely round number of 0.7.1. And for those of you who are good with dates, you will see that's the March 2018 release. What has gone wrong? What has happened? Why am I here standing under that? Well, in fairness to me, I did promise you, but I promised that in February, which is like 20 dog years ago, and I sort of hedged my bets and I said, well, I think it will have been released at the time. I'm not 100% sure. So it turns out software is hard. It is very hard to push for exciting new features and try and make everything stable. And we started off with this idea that we'll just do releases as they happen. And then we thought, well, people like reliability and they like stability. So we'll move to monthly releases. And we'll try and make every few months we'll do a long-term support release. Well, that was kind of a good idea. And, well, you know, and so it turned out after a while that the monthly releases weren't being cut on time and they weren't as stable as we wanted. So we declared a code yellow, which is a medical term, which we use some of them internally at Google. But a community, we define a set of terms. And basically what happens is code yellows are things that you ignore until you get to the next thing, which is called a code orange. And what is that? Well, thankfully, there is a very slow clicker today. There is a guide on Wikipedia which explains exactly that a code orange means a hazardous materials incident has occurred, magnitude unknown. Please return to your workstation, follow department disaster plan. Well, it's actually a little bit better than that. So basically, in the event that a release candidate doesn't pass all its tests and the next release is not ready to be used, then we say that at that point, stabilizing is more important. We want to stop work on new features and try and stabilize this release, get it to a point where we can get it out. If it turns out that we cannot do that, which is what has happened in this case, our lovely release managers on the Istio open source team have declared the next emergency, which is the code orange. So at the discretion of the operating committee, we basically did this code freeze. Everyone is hard at work on getting 0.8 released. Then the code orange will be over and world peace will be restored. Certain irony about code orange, which now having said that sentence out loud, you can all put together yourself. So, well, doesn't that ruin my talk? Sucks to be me. Here am I going to say, well, this is all the exciting new stuff that's just come out in Istio 1.0. As it turns out, as I was putting this talk together, I realized that today is, in fact, the 24th of May, the day that I was doing that talk. And if we look here at the announcement blog post for Istio last year, you see it was, in fact, Wednesday, the 24th of May, 2017. So instead, I declare, by way of clicking and facing this direction, it is indeed the first birthday today of Istio. Happy birthday. Hey, I thought that was only going to be me. Well, anyway, so please allow me to present Istio 1.0 years, time for production. Thank you. Please direct your comments to the conference organizers. Anyway, what even is an Istio? For those of you who are not familiar, for those of you who have not made one of the container camps in the last 12 months, what are we talking about? Istio is, by virtue of the lovely catchphrase from the website, an open platform for connecting, securing, managing, and monitoring services. Well, let's take a trip back and unravel what all those words mean. Behold the monolith. It was a reasonable way to do software development back in time. However, it's complicated. It's complicated to maintain. We think, hey, I've got all these great features. How about I use them? No one's going to matter. I'll cross organizational boundaries. So we get dependency creep. It's difficult to test. It's difficult to deploy because you have to deploy the whole thing at once. Because of that, you have to reduce the velocity of your development. Diverse teams have to synchronize about when it's time to build, when it's time to release. And normally these things are written only in one language, so we can't pick the programming language that makes sense for each individual module. So we do what all the cool kids do, and we decompose our monolith. We move to microservices. So everything is effectively the same, only we've got rid of the box around the outside. We've removed their crazy dependencies. We've stopped calling our internal methods from other modules, which we're not supposed to do. And we've created abstractions in the way of individual services, so each thing can be decomposed, scaled as it needs to be independently of everything else. This is absolutely fantastic. Hooray, we're finished. Let's go home. All right, well, we have gained development velocity. We can move quicker. We can test easier because we have these abstractions. We can test things independently of each other. We can scale them independently of each other. But what was the cost? We had reliable calls between the modules inside our process. We have replaced those with unreliable remote procedure calls over a network. They were secure inside the same process. Now we've replaced that with an insecure network. We didn't need to worry about access control between the caller and the callee because we were both people. There was a no-op. So we now have to worry about access control. Latency has gone up. We used to be able to single step and attach the debugger, as Gabe was talking about this morning, and we don't really know what to do now. It's very complicated. So we think, how are we going to fix it? What are we going to do about all of these things? We might say, well, I need to call you. What if it fails? I'll try again. So we add some retry logic to our code. We can add traces. We can say, this is when I entered, this is when I exit. And we have to do that on every module, in every programming language. That's toil. That's unnecessary work. We might want to do strong authentication between services, but again, we need to build that into our libraries. Every time we build a thing in a new language, we have to re-implement everything we've done so far. So the cost of doing that becomes too high, and we just go and do it all back in Java again. So what if the space between the services became intelligent? What if we could weave together a fabric, a language-agnostic fabric, where we can reload configuration on the go and abstract all of this out of our actual applications, get our developers back to thinking just about code? So we have the concept of a service mesh, which is, again, defined on the internet as a dedicated infrastructure for handling service-to-service communication, generally in a microservices environment. I like to describe it like this. It's a network for services, not for bytes. Application developers sort of think of networks as they're like pipes of bits. They don't really do much, and they don't know anything about your service. They can't do anything. So what we want is a network that operates at the same level as the services we deploy. So if you're an OSI geek, this is a layer 7 network rather than a layer 3 network. And say, well, what can we do with that? Well, it turns out we can do a few things. We can control the traffic based on what we know about it, where it needs to go, what it wants to do. If we have a service fail, we can stop traffic going to that. And again, if we have a service fail too often, we can just say, hey, I'm not even going to bother sending traffic to that because I know it's going to fail. Pattern called a circuit breaker. This fabric can provide insight. It can find dependencies on things that we did not know that we had. It can find the root causes of failure by being able to do tracing all through the call stack of your microservices. We can add security on effectively for free. Traffic flowing between services is normally, once you get on the other side of the firewall, you think, oh, I don't really care, I'm on the private part. But we don't want that. We want to be in a world where all services are strongly authenticated and authorized. And we'll show you how we can do that. Now, the question that a lot of people ask is, well, this is fantastic. Why didn't we just build all this into Kubernetes? And the real answer is that we want to be able to connect together things that run in multiple clusters. We want to be able to connect together things that run in a cluster and in VMs, or in Kubernetes and Mesos and Cloud Foundry, or any other environment you like. Because we are doing this at a network level and not an application level, as long as your thing speaks TCP, it should not matter. So we don't want to scope this down to a cluster. We want this to be a mesh as a conceptual thing that exists outside of clusters and can have services joined in. As we've started, it's obviously been much easier to run the control plane and all the services in the same cluster, but we've added on work over time to make it possible to do VMs and a single cluster, and now as we move to our later releases, multi-cluster as well. Why did we start Istio? Well, it turned out we were looking at this service broker ecosystem. We don't want to say, hey, connect this thing to a database that I have installed and provisioned over here. We like the model of saying, call the broker and give me a database. It might be that your platform has a database service and it can provision one for you. It might be that your environment says, hey, if I've been asked to give a database, I can run this. I can spin up pods and turn on a MySQL instance myself. But ultimately, the application developer should just say, this needs a database, and then the system, by way of policy, should be able to choose how to implement that. Very common in the Cloud Foundry ecosystem. We started thinking about what would it take to enable the Kubernetes ecosystem with this. Say, well, ultimately, we want the same thing. We want to be able to say anything we can connect from our own code that we write needs all of these things, even when we don't know what the thing on the other end is. It's not like we can plug our libraries in, because it might not even be something we operate. It might just be something we consume from somebody else. So we had a look at what we did internally. We have our teams who have been working on this, building load balancers inside our network and outside for many years, who have been looking at ways of deploying jobs into our clusters and deploying sidecar-like environments with them. And that's the team that is now building Istio. Around the time we were looking at open sourcing this, we went and said, all right, what's out there? What's this kind of state of the art in this? Who was familiar with Amalgamate when it came out? Anyone? I'm going to say that's clearly no one. So Amalgamate was a system put out by IBM. It was about late 2016, I think. So it was around the same time as we were starting publicly thinking about Istio. And it is very Istio-like. It uses Nginx as its proxy instead of Envoy. But it was very similar in terms of the traffic control pieces of Istio, thinking how would we attach this proxy to applications that ran in cloud environments and then program it in a way that we can give it rules and so on. And we reached out, as we do in the open source world, to IBM and said, hey, we're going to start doing something like this. We see you've got something in this space. Do you want to work together? And they said, yes, that's fantastic. So we did. The next thing we needed to do was decide, well, what are we going to use as the engine? How are we going to power this? Who's familiar with sidecars? Things on motorcycles, etc. So basically, a sidecar is just something where you deploy a job or a pod or some piece of work and you attach something to it, and you hopefully assume everything in your cluster that gets one gets the other. Kubernetes obviously makes that easy with the concept of pods. You can say this pod has more than one container in it. So I can deploy my workload, and I can deploy something that needs to run with it in order to do something. And that might be to translate or to provide security or provide a tunnel to some other application. With this Kubernetes environment, it was very easy to say, we're going to sort of outsource all the work of doing the connectivity and all the network pieces to some kind of engine, to a proxy server, something like your Nginx's or HA proxies of the time, that would serve this purpose. And the one that we settled on was Envoy. Envoy is a very modern implementation of this idea, conceptually very similar to some of the things we do in Google. It's written in C++. It is very idiomatic, modern C++, I should say, with a very low memory footprint. And it was written by Lyft, the car-sharing company. Lyft operate in Australia? Don't think so yet, but they should. Lyft had this running in production for about 18 months before Istio came about. So the engine, the data plane of Istio was a real thing that people were able to use that was battle tested. So we said they were running over 100 services, 2 million requests a second at Lyft using Envoy. And more importantly, the Envoy team were fantastic. They were very willing to work with us. They were very willing to work with IBM. We said, we have these ideas about how our two teams can contribute back to Lyft, to Envoy, and make the proxy better for everybody. And they said, yes, that's fantastic. Let's work together. So great choice. Very happy with that. So that is where Istio came about. Now, Istio has been open source since November 2016. Sorry, it's been on GitHub since version 0, November 2016. As I mentioned before, it has been public since 1 year ago today. This is an example of a simple Kubernetes deployment. The white box represents our cluster, so we can have services that run in pods with different numbers of replicas inside our cluster. They can talk to services that are running on the same network but are not inside the cluster. So we might use Cloud SQL, our hosted database product, or we might call from one of our services out to something completely external, like a software as a service for payment gateways. With Istio, we take the spec of the pod that we want to create. In this case, we want to perhaps create a deployment which has multiple pods, and we'll talk about our front-end application. In the very, very simplified version, that is what you need to tell Kubernetes to be able to create a pod. Minimum is you say, what is the image that needs to run? In order to enable the Istio sidecar to run with your application, you pass it through some sort of a tool which adds the Istio configuration on. There's two different ways you can do this. Hello? Sorry, we good? All right. You do it with a command line tool that is provided with Istio to inject the Istio magic inside that deployment file. Or you can deploy a hook into your Kubernetes cluster, which means that when you submit anything to the API server, it will add that on for you automatically. And effectively, you end up in this state where you have a pod that is now deployed with two containers inside it. It has your provided code, front end, and then it has the Istio proxy, which is the Envoy binary and some configuration and so on for it. And there's also an initialization container, which does the work of configuring that pod to say all traffic that comes from anywhere, instead of going to the user service, now goes to the proxy. And all traffic that comes out of the front end has to go out through the proxy as well. So we are effectively hijacking, man-in-the-middling, if you like, all of the traffic so we can do all the things we want to do. And now it looks like this. We have an Envoy there as an ingress or a gateway, and then we connect to the services. You'll see that the lines don't go directly to the user-provided work anymore, but they go to the proxies. The proxies all talk to each other. They are the only things that communicate now on the network, and that will be important. We'll see in a second. How does Istio work? As with all cool things, we have a control plane and a data plane, which are independent of each other. There are three main components of the Istio control plane. The first one is the pilot. Pilot is basically the thing that matters. If you're using the pilot, you're using Istio. Pilot is a tool which programs the Envoy proxies. It tells the proxies what to do in the case of rules that are provided to it in a similar way that you'll provide YAML to Kubernetes. It also handles discovering the services that exist on your cluster or in other environments and configuring the proxies so that they know when this proxy wants to talk to another service, where it is on the network, what it can talk to, and as we'll see in a second, sort of where it will route traffic. The next service is the mixer. Mixer does policy enforcement, and it also does plugins for metrics and visualizations and telemetry and so on. So the mixer is what basically checks to see if you're allowed to make a request. When someone wants to make a request, so front end wants to talk to payments, it will be transparently redirected to its proxy. And then the proxy says, am I allowed to do this? It calls the mixer and says, they want to talk to them. Are they allowed to? We can have things like quota. Have they spoken too much? Or rate limiting. Are they speaking too fast? And if it turns out they're OK, we can say, all right, yes, that's OK, and you can trust this for a minute or so or certain thousands of requests so that we aren't always calling the mixer. We're able to cache some of that locally. Then it also gets, out of band, it gets sent some telemetry information. The mixer gets told, this is when I started the request, and this is when I ended it. And also some tracing information if you enable that. So that it can then connect to your logging backend, or Prometheus, or Open Tracing, or Zipkin, or something. And it is the point which does all of the, or one or more of the mixers you run in your environment, is the point so you don't actually have to have all of your proxies individually talking to your logging and monitoring backends, and you can swap them out if you need to. You can replace them in flight, which is great. The last piece is, it's going to be called Citadel now. It's been called Istio Auth up until this point. which is basically a certificate authority and a mechanism for distributing certificates to all of the proxies. So what we can do is we can say, no things on this network may speak to each other unless they are strongly authenticated and encrypted. And we'll see that in a moment as well. So we have a request come in for our front end. It talks to the proxy. It doesn't know it's talking to the proxy. It thinks it's talking to the front end. It'll handle that transparently there, call out to wherever else. And again, if it needs to talk out from the payment service, again, we'll get service out. The applications don't know that Istio is running. Very important. You don't need to change anything about your application to use Istio. Three main things that we think of. Traffic control. First of all, we tied our network connectivity to our infrastructure with Kubernetes. If you call into a particular service, say, well, what if I wanted to say 10% of my requests go to V2 of this service? It was a demo we used to do in the early days. How we would do that is we'd deploy 10 of them, or 11 of them perhaps. And then you just happen to, by the fact that we go round robin through them, every 10th request would go to your new service. So yes, I've achieved my goal, but I didn't really want to have 11 services running. I probably only needed 2. So we had our traffic control tied to our infrastructure. With Istio, we can program and say, all right, I want 10% of my traffic to be canaried. And then the proxy will say, all right, for every 10 requests, I'll send one of them to this service and then the other 9 over there. And I don't need to run more infrastructure than I need. You don't only have that at the front end, like you could with a load balancer. You can have this between services. So you might want to say, between these 2 particular services, I will route 90% of my traffic to v1.5, and then the remaining 10% to v2. But because this is a layer 7 thing, what we can do is we can do traffic steering, and we can say, we know something about this traffic. We can look at its HTTP header and say, that's coming from an iPhone. It has a host header. We might want to test a particular service and say, we're testing this for iOS devices. So we'll take all the traffic, or even a percentage of the traffic, from iPhones and direct it to the new service. So we're not wasting time sending traffic that we don't need to test to a new service. Traffic steering. Now, the second pillar of Istio is this observability piece. So you get out of the box a lovely dashboard that's Grafana powered by Prometheus, which shows you what's going on in your cluster. You don't have to do anything. You install Istio, and that's there for free. You can get response times for connectivity between versions of all of your services that speak to each other. You can see your latencies at things like 50th and 95th percentile. You can see requests per second and success rates and things. And that's hugely useful when you think about that case where something's failing and taking a long time and you don't know what it is. You can use this to start drilling in. And you can go into the Prometheus dashboard and drill in further. You can solve the tracing problem. Again, one simple command line installs Zipkin into your cluster. The mixer gets puts headers, the envoys put headers on, which mean you know when you're going in, you're sending a request out, you know what time it was when you came back, and it can connect these together. You don't need to worry about aggregating the spans. And then you just pass them through to your tracer of choice. And then you can see what's going on and the various latencies between microservice calls. Then, as I mentioned, the security piece. So today, anyone can call a front-end service, and that could cause a request to go to your payment service. And that's not verified. You could be giving payment data to anybody that happened to be running on your network, especially if they found a vulnerability in one of your other services and then use that to get further in. So when our endpoints are trusted, like we communication in the clear, it's not really good enough these days. We want to be able to know who everyone is and encrypt them. So we can use the Citadel component, which issues identities and certificates to each service as they're deployed, rotates those credentials over time. And now the front end will only connect to a payment service if it has a signed certificate attesting that it is who it says that it is, and vice versa. And these identities can be passed to the back ends, so that the identities can be used for enforcing policy. So for example, only the payment service is allowed to call out to your external bank environment. Now, what would encourage people to run alpha pre-1.0 software in production? When we put a big flashing red label on it saying not ready for production, don't use this. Why do people do it? There's got to be a reason. Descartes Labs are a company who use satellite imagery to model systems and look at things like global food supply and detect early warnings. They were the first known user of Istio in production. We launched it in May last year, and they went to production in September on 0.2, 2 months after we launched it. So why did they do this? Well, they were an early adopter of Kubernetes. They're a GKE customer. And they think, that's fantastic. And they've got this lovely application. And then one day it's slow. And they're like, why is it slow? And they say, I don't know. It's fantastic. I can roll stuff out, but then it doesn't behave. And I've got no way of knowing why. So just by installing Istio and getting those dashboards that you saw before, you're able to start finding that out. So aside from all the cool stuff you can do with fault injection and then figuring out what it would look like if this thing took too long and called something else, for example, you can just see what's happening inside my cluster. It enabled them to get the view inside their applications they were previously unable to get, solved a real problem for them. They were willing to put that into production straight away. Namely, are an HR company running on Kubernetes on AWS. They were quite advanced beforehand. They had 2 monoliths, not just one. They were running 2 monoliths. So they wanted to move to a microservices environment so their developers could only focus on their business logic. So by using Istio, they have automated the metrics around their RPCs. They've randomized retries with exponential backoff. They're doing all the things the SRE book says are fantastic. It cuts down on their toil. It cuts down on all the work that they have to do otherwise. And one thing similar to what Gabe was talking about this morning, about namely that I wanted to mention, is the way that they do their testing. The local developer says, I'm going to work on a particular service. They're going to work on a new version of service B. They use a thing called telepresence, which is a CNCF project now, I believe. But it enables you to run a little proxy between your production environment, which will pass traffic back through to the developer's laptop. Now, with Istio, we're able to say, if I get a request come through which has a header says it was sent by the developer who is working on this thing, then when service A goes to call a particular thing, it's not going to call the service B that's running for everybody else, but instead it's going to call B prime, which is running on that developer's laptop. So they're able just to do their debugging locally. They don't even need to make a container and push it up to their cloud. They're able to continue developing locally on that particular thing, and no one else is affected. It is solely traffic that has a particular header put in by that developer. It's a very cool thing. One more company who's publicly talking about running Istio in production is the weather company. They had 40 microservices that are backed by VMs, and they have an API gateway layer that's in front of it that does edge caching. And they were deploying that, basically, in order to make any changes to their routing, they'd have to redeploy that gateway, and they're only able to do that about once every 2 weeks. They really wanted to be able to have self-service switching routing quickly. And they wanted all the other things like retries and be able to do canaries and blue-green deployment and everything. So they've been testing Istio, and they're going to roll out this particular service in 0.8, which will be coming out soon. But they are actually running some services in production with Istio 0.7 today. So they are the last company I can show you a logo for. My colleague is one of the program managers for Istio, likes to talk about this concept of Istio a la carte, where you don't need to adopt the whole platform at once. You're able to say, I'd really like that observability, but I'm worried that the mixer pieces, they might be a bit buggy and they might take things down. So what would it look like only to adopt certain pieces? So some more customers who are running with this who we don't have permission to name yet, but they really want to be able to get one of these pieces, and they've decided that the safest way to achieve this at this point in time is to adopt only one of the particular functions, and they'll look at building the other ones on later on. So we talked about Descartes. They're in the sort of what's going on, I just want observability piece. They don't necessarily need to have any of the authentication, so they don't deploy that. Another customer has an interesting environment that they have. They're a multi-tenant SaaS provider. So they'll do a deployment of some work for every one of their customers. But they have no service-to-service communication. These things do not talk to one another. Everything is from the outside to the deployment that's done for that customer. So they didn't bother using the sidecars. They don't need the sidecars for this because we're not trying to intercept things. But what they did is they just used the Istio ingress. So they're able to get visualization and so on of the traffic going into each individual service, but they decided not to use that injector and not to use the sidecars. We have another customer who is using, this one's a GKE customer, and they have a service that's using gRPC, which uses HTTP2. And that is something that, being more a TCP-based protocol, most load balancers are not aware of what to do with that. So they have 100 services, and they have test and staging and production environments. So that works out to be 300 services. And they have a single Google load balancer in front of each of them. So that's a lot of load balancers. They are paying a small portion of their bill, but it is still thousands of dollars a month that they don't need to be paying. So by using Istio, by using the Envoy proxy, which is aware of how to load balance gRPC, they're able to cut that out completely, save themselves a lot of money. Finally, we're seeing surprising uptake in the banking and financial services sector, which is people who are not famous for using microservices and possibly don't care as much about canary deployments as you might think. But what they do very much care about is being able to prove to regulators that everything on the network is encrypted and that everything is secure in that fashion. So by using the Istio auth components and then deploying those sidecars, pushing out certificates, we can guarantee that all traffic on our network is encrypted, and if anyone was able to get access to our network, then they would not be able to read anything. This is a really good thing in cases where people would size their subnets based on their expectations. We had one customer who says, I've got subnet A, we'll call it a /24, and we've got subnet B, and we have different things in them. It turns out that they've filled up subnet A. They've got lots of spare IP addresses on subnet B, but they cannot use them because they're in a different subnet. And they just wanted to be able to shrink that one and grow that one. Well, you know, that's not how networks work. If you had a flat network, and if you did all your authentication and authorization in software using something like this, you wouldn't have that problem. You don't care what the network is like. You'll let your applications do all the auth for you. So that's my advice as we start looking at how to run Istio in production, is start small. Everybody needs something, but not everybody needs the same something, and you may not even need everything. We've done a lot of work as we've moved through the last year to make it possible to install parts of Istio and not the whole thing. If you don't need authentication, don't use it. It makes it a lot easier to connect to things that are outside of your Istio cluster if you don't enable that. Pick the features that matter to you, adopt them, and as everything else becomes more stable or more interesting to you, you can move on to them as well. So, what's next? Well, Istio 0.8 is clearly the next thing on the list. It is due in a release candidate form by the end of the week, and being that we're in the future here, it'll be by the end of the American week, so maybe over the weekend. And by the end of next week, hopefully, he says, being several months behind on this as it is, we should have a release of 0.8, and that will be the first LTS release that we have had since 0.2, which came out sort of September last year. That is introducing a whole bunch of breaking changes. So we have looked at the way that we published our route rules and so on and said, well, it turns out we think we've got a better idea of how we would do this. So we've revved a couple of the APIs and renamed a bunch of objects. So very sorry if anyone who went through the workshop yesterday, everything you learned is now wrong. But it's pretty easy to fix, and there's a command line tool that will change all the YAML for you. And that will get you to a point where you are able to use something which we have confidence is not going to need to change a lot. When we launch these things, we say, all right, well, we have a particular bar we set as to what 1.0 means. And it might be that we lock down the functionality quite far in advance of this. Pretty much everything that's in Istio 1.0 was in 0.1 as well. We haven't had to add a lot of stuff. We've renamed a couple of things. We've made it a lot easier to do everything. But all the basic ideas were there. And in order to get to this point where we think is production ready, we need to say, all right, we're not going to add new things. We might change the color of the bike shed, but we're not going to rebuild it at this point in time. 1.0 will be a guarantee. It'll say, not only will the API in this version not change, we'll have a deprecation policy and all those cool things that projects have, but hopefully we're not going to have too many changes, and 0.8 is a candidate which we recommend that you look at for long-term support. As for a potential Istio 1.0 release, that will be API complete. Some features in it will still follow the model, the Kubernetes v1, alpha 1, beta 1 kind of API model. So not everything may necessarily be stable. But that is the point where we say we are not going to change everything in the base model until we rev the major version number. And 4 years into Kubernetes, we're still on 1 point something. So that's unlikely to be necessary. We'll have a lot more test cases. We'll have a lot more solid an idea of exactly what it means to install Istio, like what the extra CPU usage and network usage and so on your cluster is when you do this, how many requests per second you can put through in various situations and so on. And realistically, Istio 1.0 will launch sometime in Q3. And I don't know if there's planned to be a 0.9. I think we'll probably see how 0.8 goes. So in closing, again, happy birthday to Istio, 1 year old today. If you're interested in this kind of thing and listening to me talk, I've just launched a podcast recently with my colleague Adam. It's called the Kubernetes Podcast from Google, and feel free to get your phones out and type that into your favorite podcast client. I'd love to get feedback from you, but that's how you can find me on Twitter, and thank you very much.